All right, let me ask you something. Have you ever looked at a simple grid, just a bunch of squares, and wondered how many rectangles are really hiding in there? It seems so simple, but the answer? Well, it's way bigger than you'd think. Today we're going to dive into the art of counting, and you'll see how just changing your perspective can crack a problem that seems almost impossible.
So, our journey starts with a puzzle that looks super straightforward. Something you could easily just sketch out. But as you're about to see, there's a lot more going on than meets the eye. Take a look at this. It's a plain old 8x12 grid. Nothing crazy, right? Just a bunch of lines. You've seen this a million times on graph paper or maybe a spreadsheet.
But here's the real question, the one that stumps everyone. How many different rectangles can you actually find inside this thing? And I mean all of them. The tiny little 1x1 squares, the long skinny ones, the big chunky ones, even the whole grid itself. Seriously, where would you even start?
Now, if your first instinct is to just start pointing and counting, well, you're going to be here for a very long time. That brute force method is just a recipe for a headache. But don't worry, there is a much more elegant way to do this. A shortcut that completely changes the game.
The secret weapon we're about to use is this really powerful idea from math called combinations. It's basically a tool that lets us count groups of things without getting lost in all the little details.
So, what is a combination? Let's make it simple. Imagine you've got 5 friends, and you need to pick 2 of them to go see a movie. A combination, written as C52, tells you exactly how many different pairs you can pick. And here's the crucial part. The order doesn't matter. Picking Sarah and then John is the exact same thing as picking John and then Sarah. It's all about the final group you end up with.
And here it is. This is the big aha moment. This one little idea completely unlocks the puzzle. Instead of trying to count rectangles, think about what it takes to make one. All you need are 4 lines, 2 that go up and down, and 2 that go side to side. Anytime you pick 2 horizontal lines and 2 vertical lines from our grid, boom, they automatically create one unique rectangle.
Okay, so now that we have that amazing trick up our sleeve, we can finally solve our grid problem. See, we've reframed the whole thing. It's not about counting shapes anymore, it's about choosing lines, and that makes all the difference.
First things first, let's count our lines. If you have a grid with 8 rows of squares, that means it's actually made up of 9 horizontal lines, right? And a grid with 12 columns of squares needs 13 vertical lines to define them. So our job is to pick the boundaries for our rectangle from these 2 sets of lines. So here's our game plan. First, we're going to figure out how many different pairs of vertical lines we can possibly choose. Then, we'll do the exact same thing for the horizontal lines. And for the grand finale, we'll just multiply those 2 numbers together to get the total.
Let's start with the vertical lines. We need to choose 2 from the 13 that are available. So we use our combination formula. That's C13-2. The math works out to be 13 times 12 divided by 2, which gives us 78. So there are 78 possible ways to pick the left and right sides of a rectangle.
Okay, now for the horizontal lines. We need to choose 2 from the 9 available lines. That's C9, 2. So we do 9 times 8 divided by 2, and that gives us 36. That means there are 36 different ways to choose the top and bottom of our rectangle.
And now for the final step. We just multiply our 2 results. For every single one of those 78 vertical pairs, there are 36 possible horizontal pairs to go with it. So 78 times 36 gives us our grand total, 2,808. Can you believe that? 2,808 rectangles were hiding in that simple grid. Just imagine trying to count all of those one by one.
So that combination trick was pretty slick for our grid problem, right? But the true art of counting is knowing you have different tools in your toolbox. Let's try a new challenge that needs a totally different but just as clever strategy. Okay, picture this. You're in a classroom, and the floor is covered in a 5x7 grid of tiles. You've got a 3x4 yoga mat. Now, you can lay it down horizontally as a 3x4, or you can turn it on its side and lay it down vertically as a 4x3. The question is, how many different ways can you place that mat on the floor?
For this one, we're going to use a new strategy. Instead of choosing lines, we're just going to count the possible starting spots for the mat's bottom left corner. So let's start with the horizontal 3x4 mat. On our 5x7 floor, there are 3 possible starting rows and 4 possible starting columns for that corner. That gives us 12 total placements. Now we flip it vertically to a 4x3 mat. This time there are 2 possible starting rows and 5 possible columns, giving us 10 more placements.
Now we just add them up. The 12 ways you can place it horizontally plus the 10 ways you can place it vertically gives us a grand total of 22 possible positions. See? A different kind of problem called for a different but still elegant solution.
So what's the big idea here? What's the main takeaway? It's not just about learning formulas or counting corners. It's about something way more powerful, the art of reframing the problem itself.
Here's what I hope you take away from this. Just trying to power through a problem, brute force, is almost never the best way. The real skill is to take a step back and look for a hidden structure, some underlying rule. That single insight, like defining a rectangle by its lines, can turn a monster of a task into something super simple. The true art of counting is really about choosing the right strategy for the job.
And that really brings us to the final thought. This whole idea of reframing a problem, it's not just for math puzzles. It works for everything, in business, in creative projects, even just in your day-to-day life. So the next time you feel stuck on something, just ask yourself, is there another way to look at this? What complex problems in your own life could be solved just by changing your perspective?